Alright, for part B, we say that region S is the base of a solid whose cross-sections perpendicular to the x-axis are squares. Find the volume of the solid. So remembering from part A, if you want to see how we got that, look at the previous video. We know that this bottom here, which is the top there, is F, and the top here, bottom there, is G. We also know that the x value of this is at approximately 1.032 8319. And so S goes from 1.033 approximately all the way up to 2. I'm going to use that in my integral. I called this the variable a, and I stored it into a in my calculator already. Okay, so we know that this is the base of a solid. Cross sections are squares perpendicular to the x-axis. So if I consider this is where a square cross section is going to fall in there. So I'll call that S for side length, which means I have this little square. The square is, of course, S by S because it's a square. The area of this square with respect, or in terms of its side length, is S squared. Its side length, though, we can see is found by doing this top function minus this bottom function. That's the distance between the two functions at that x value. So I need to rewrite this in terms of x so I can integrate from this x value all the way up to 2. So this area in terms of x will be f of x minus g of x squared. And then to get the volume of the solid, I just integrated that area function, so integral, from the starting x value to ending x value. That's how I'm determining that in terms of x. So from a, already stored in the calculator, all the way up to 2, of this area function, which happens to be f of x minus g of x squared dx. And I'll go into my calculator. I'll show you a already holds this value in it, and I'll just do math integral of f of x minus g of x. I'll retype them in. They are already stored in y1 minus y2 from part A, but I'll retype them in here. So 1 plus x plus e to the x squared minus 2x. So that's going to be f. Let me put a second set of parentheses in here so I have everything good. So that was f of x, close that off, minus g of x, which is x to the 4th, minus 6.5x squared plus 6x plus 2, close that off, that's g, all squared. And it actually doesn't matter f minus g or g minus f if it's positive or negative. Technically this is the side length, but if you flip it around and square it anyway, it'll make it positive to get the same correct answer. It's still technically going to be the area of those cross sections. I'm going to integrate that with respect to x from this a value up to 2, and I get, once it goes through this work, approximately 1.283. So approximately equal to 1.283.